Hello everyone, and welcome back to another lesson learning with Rymer. We're going to look at our series parallel circuits. This is part 3 of a 3-part mini series, solving equations in electrical circuitry. I have here drawn out a series parallel circuit. I've got my series portion that has a single 2 ohm resistor. I have 3 branches, each with its own resistance value. And we're going to take a look at how to solve this entire equation. Now, the first thing that I need to know how many amps are going to be flowing from this battery. And in order to figure that out, I need to know what the total circuit resistance is going to be. The method that I like to use to solve these types of equations is what I like to call the substitution method. So our first step, because we don't know how many volts this resistor in the series portion is going to use up, I need to first turn this entire parallel portion here into a single resistance value so that I can determine how many amps are going to flow out of that battery. In order to do that, I'm going to redraw this over here. Now I have my parallel portion drawn over on this side of the board. What I'm going to do with this parallel portion is I'm going to apply a theoretical voltage. I don't care what that number is. It can be whatever you want. It can be 272. It can be 1. For easy math, for my resistances, I put 6, 3, and 2, all easily divisible into 12. And I did that just for the sake of showing how the math is done. Now I forgot to draw my resistors in here. So just for argument's sake, we're going to apply first 12 volts into this, and then we'll pick just a random number to show that it doesn't really matter what voltage we use here. For this instance, I'm going to start with 12 volts, and on each branch, I'm going to get an individual amperage draw. My 6 going into my 12. If I want to draw it out, it'll look like this. 12 volts at the top and 6 ohms will give me 2 amps drawn across that first coil. I'll continue down with the process. My 12 broken down into 3 groups is going to give me my 4 amps. And my final branch, my 12 divided by my 2 ohms, is going to give me 6 amps. We still have to use all the same rules from our series and parallel circuits that we talked about in the 2 previous videos. With my parallel circuit, my amperage is going to be added across each branch. So if I add these up together, I've got 6 amps, 4 amps, and 2 amps. That should give me 12. I'm going to take that 12 amps and I'm going to apply it to this 12 volts to give me my total resistance of this entire parallel portion. It's going to give me 1 ohm resistance of this entire portion. Now, just for math's sake, let's apply a random number to this. Let's replace that 12 with 222, just for argument's sake, for the substitution method and applying that. If I have a 6 ohm resistor, I'm going to divide that 6 into 222. It's going to give me 37 amps. Okay, next, I'm going to take the 222. I'm going to divide that into 3, 74. My 222 divided by 2 is going to give me 111. Now I just go through the same steps. That 111 amps plus the 74 amps plus the 37 amps, if I add those 3 together, it should give me 222, which I then put that 222 amps into the 222 volts. That'll give me 1 ohm of resistance. We ended up with the same result. So it doesn't matter what number I apply here. Once we've figured out the resistance value of this parallel portion, we're done. We don't need this anymore. I'm going to go ahead and erase this, and I'm going to turn this equation into what we just did with this math. This is essentially what we've done with this equation. We have our 2 ohm resistor, we transcribed that back over here, and we turned this parallel portion into one value of 1 ohm. In doing this, we can now take these numbers, apply them into our 12 volt system to give us our total amperage that's leaving that battery. Because if we look back at our series descriptions, all the current that leaves that battery is going to return back to the battery. What changes is in the parallel portion, that amperage breaks up into 3 different values depending on the resistance of each of those values. To figure out my total amperage draw, I'm going to add those 2 resistors. 2 ohms plus my 1 ohm is going to give me 3 ohms. That's my total resistance of this circuit. I'm going to put that into my 12 volts that's leaving the battery. Let's put it into a triangle instead. 12 volts divided by my 3 ohms is going to give me 4 amps. I have 4 amps total in this circuit now. So I'm done with this as well. I don't need that anymore. I know leaving my battery and returning to that battery, I have 4 amps. That was the whole purpose of the substitution aspect of this equation solving. My next step, I can now count or calculate how much of this available 12 volts is going to be used at this 2 ohm resistor just by multiplying across. My 4 amps flowing through my 2 ohm resistor is going to consume 8 of the available 12 volts before the parallel branch even sees any of it. So down here on this voltage meter, I'm going to have 8 volts consumed. That 8 volts is going to be taken out of the 12. That leaves 4 volts at each of these branches. Now, as we know and as we talked about with our parallel circuits, all the voltage is going to be consumed at the available resistors. Let's just assume that we don't have any unwanted electrical resistance in this circuit. All 4 of these volts are going to be used up. We're going to divide this 6 into the 4 volt. Gives me 0.6 repeating. We'll go down and we'll do that for the other 2 branches as well. Now I've got my 3 amperage draws across those 3 branches in the parallel portion, all 4 volts being consumed in each one. That gives me 3 numbers of 0.6 repeating, 1.3 repeating. If I was to add those 2 together, I'd get 1.9 repeating. We'll round that up to 2. And then on my 3rd branch, my 4 volts into the 2 ohm resistor is going to give me 2 amps drawn across there. If I add those 3 together, the 2 from these 2 plus my 2 gives me 4. That's my total amperage leaving that battery broken up into the 3 branches. I've solved now everything that I need to know about this equation. So it's a little bit of a different method to approach a series parallel. And if you found this video helpful, make sure to do the stuff at the bottom. My goal is to help one more person than beyond the scope of my classroom. And if I've done that, then I have been successful. Thanks for tuning in, and we'll see you next time.